So let's solve this single order differential equation. First of all, I'm going to rewrite this simple notational change just to make our lives easier. Dy by dx plus x squared y equals 0. This y prime and dy by dx is exactly the same thing. It's just the two different notations, right? And it'll be easier in this context. Now, what I'm going to do is I'm going to multiply it through by dx, so we get dy plus x squared y dx equals 0. And then we're just going to move this around. So we have everything, dy is on one side and dx is on the other side. So we have dy equals minus x squared y dx. And we can solve to bring this y to the left side. So we get 1 over y dy equals negative x squared dx. Okay, so this is, now it's pretty familiar now, right? We can solve this fairly straightforwardly. We can just take the integral of both sides, okay? So that gives us the natural log of the absolute value of y plus c equals minus x cubed over 3 dx. Sorry, oops, not dx, plus c. Okay, so we have two arbitrary constants on each side. We can just combine them and just refer to both with just one c. Okay, because simply adding two arbitrary constants together is another arbitrary constant. So c plus c is still just c, right? Because c is not a value; it's just it just represents an arbitrary value. That could be anything. So now we need to solve for this y. So the first thing we can do is we can take the exponent of both sides. Okay, so I'm just gonna put that in a different color, say that. Oops, that's terrible. Okay, take exponent of both sides. All right, that's just gonna give us the absolute value of y equals e to the power of minus x cubed over 3 plus c. All right, so now how do we get this? How do we create something that's just this y on its own without this absolute value function? Well, first of all, we can recognize that we can rewrite this as e to the power of minus x cubed over 3 times e to the c. That's just a rule of exponents, right? So I'm just gonna, so this is because, so for example, e to the a plus b equals e to the ab. So I'm just using that property to separate these two out. So we have the absolute value of y equals this thing. So what this is saying is that no matter what y is, the positive value of that number is represented by this function. Okay, and indeed we can see that that's true, right? So if x is a negative number, if x cubed is a negative number, this is just 1 over e to the something, right? So, and we know that the exponential function can never be negative, right? So the exponential function looks something like this, right? And it looks something like this, right? That's pretty. There you go. That's better. Okay, so it's never negative. All right. So what this is telling us is that this side is always going to be positive, right? So given that, how do we solve this so it's just y? What we need to show is that no matter what value y takes, it could be negative or positive, this function will always give the positive value of that y value, right? So what we're saying, so we need some way to show that. So what we can say is we can say y equals d e to the minus x cubed over 3. Essentially, we're saying that this could be e to the c times, so essentially what we're saying is actually this, right? We're saying that it's minus 1, it could be minus 1, y could be any of these. Y could be minus 1 times e to the c e to the minus x cubed over 3, or y could be e to the c e to the minus x cubed over 3, right? So we can just say that as y, so we can incorporate the e to the c and the sign change into one number d, and we can call that e to the minus x cubed over 3, right? So this could be a negative number, and this would still work. The absolute value function would still work. This could be a positive number, and the absolute value function would still work. Okay, so this is our answer.